Okay, we should be live now in Twitch, YouTube.
Okay.
Okay, so this is a fifth all hands meeting, but technically a second. But I'm trying to keep my numeration, and the agenda is to just synchronize with you guys in Brno, right?
Mhm.
Okay. I can share a screen, or I don't know what are we going to talk about.
Yes, basically, I wanted to introduce my colleagues. At least Tomasz will join us soon. And I wanted to discuss with you the problems and goals which are described like on the Graph Notion side.
Mhm.
And also we can discuss like the possibilities of the future cooperation somehow, or not discussed because we discussed it the last time already, but we can talk more about it, and we can be more specific with the goals we would like to achieve in our cooperation and such.
Yep. I'm just trying to formalize because I'm not that good at speaking, but I'm more good at writing things down on like shelves, so that I can make some kind of decisions later on. And I'll share a screen, and this is also again up there in internet somewhere. So the recording will be available later on. Past recordings, I think I put them somewhere, so they should also be available. Okay, my internet is getting, or my computer is getting really hang of all of the video processing, and I'm also running a bunch of Docker containers, so it is kind of very sluggish. But I think past recordings were somewhere here in all hands, and because this is a, let's say, v2, and agenda is to basically sync what you did, or sync what features I wrote down, and the cooperation. All right. Yeah, and we have also Zain here, right? Or like, you have a long name. It's Mohammed Zain. He's from, I think, Pakistan,
Mhm.
and he is I think more focused on like CAD modeling. So he was looking into designing a model for robotic beehive. So the like how the frames, how the mechanisms should look like, because I did only like a prototype and a sketch. So just a drawing. I was thinking out how to do it. He's actually trying to formalize it into a CAD model so that it's more precise and more things are taken into account. We have also Alexei, who, so under team, I try to write down competences and what who is like working more in what. So Alexei is more on C++ and kind of backend engineer. So he's looking into humidity monitoring and maybe heating, and sending this data to the cloud. and we have Ahmed, who is I think he was present last meeting. So if you want to watch the recording, I was explaining him also the app, and he took a task with telemetry API, so which is it's like a service in the cloud which should accept this this data that Alexei is working on. So this should give us some kind of live data about, you know, some numbers. So if humidity or temperature is a concern, then we can track that somehow. Yeah, so I try to write down who's working on what, competences, a kind of activity is just my subjective number. I change it all the time because I had other people who were sort of interested, you know, or who participated in some hackathon, and then they kind of silently dropped off, which is fine because it's a volunteer work anyway. So I don't expect anyone to work really hard for free. And yeah, that's why I kind of just try to have this picture in mind, who's working on what. And I don't know if I should go through the project again, or like the vision, or should we wait for Tomasz, or
Maybe we could wait for Tomasz a bit. If you wouldn't mind, I was looking on the problems you are solving on the Graphon Notion side. And I think that me and, let's say, my colleagues from Total would help you with several of those problems, because they are somehow solved already by our previous work. Especially, it is the, let's say, the detection of the colony without a queen, the swarming, and in theory also the horned attacks and the colony starvation, maybe also the hive ventilation. Basically, the thing is that the last year I was not officially, but I was supervising a thesis where I'm written as a consultant. I sent it to the chat. And I mean, slightly, it's a bit complicated because the thesis is written in Czech, but I guess for some idea about it, it is also possible to use some kind of machine translation. And in this thesis, Stephen was working on my demonitoring device, and he was focusing on processing the of the sound data, which are taken with the microphone. And because the data set I was presenting the last time is still under development, he found several other datasets which contained more annotation data, and it seems that quite efficiently some of those stuff or states of the bee colony could be effectively detected by using the sound analysis, using the model spectrogram, which is basically transforming this problem to the image domain.
And do you use like a transformer model to treat sound as an image?
I mean, it might be also an option, But the null spectrogram is, let's say, an analytic tool which is not a deep learning based.
Okay. So kind of something like
It's like a traditional method.
LSTM or okay,
It's
like
more
statistical method, some kind of okay. Okay, we have.
Great. Tomasz, 2 minutes.
Yeah, I apologize profusely.
Hi.
Sorry, I'm here now.
Great, great to have you, Tomasz. Just a reminder, we're recording this session, like other sessions as well. So just so you know. Okay, so you're using some not deep learning model to analyze sound. Yeah, I was.
It's a kind of spectrogram,
Mm-hmm.
which is more focused to model the presentation of the human ear. So somehow it uses the logarithmic scales and such. And basically the output of this is an image which somehow looks like a spectrogram. And my student used those images to extract the features. To be honest, I'm not sure which methods did he use, but I think he was experimenting with PCA and Disney. And quite efficiently, he managed to detect, for example, using the cluster analysis, he managed to identify, for example, the state where the queen is not accepted by the hive, or when it is not present. And I also believe that it could be effectively be used to detect this danger of this forming, because even on those data which are not annotated in this moment, so if you visualize them, you could see that there are like more clusters which are quite well separated, I would say.
Mm-hmm. Okay, that's good. I mean, the whole idea to use sound. I had similar, like I actually added the similar idea or like feature. I just don't have any experience in it, and I think I heard about this somewhere as well. That like research scientists do use this, and I think B Hero also uses sound to detect. I don't know exactly which features, but yeah, that's in use in production. I have this over here under 6-channel audio monitoring I was thinking of, but I don't know how many, like how much did you use?
Basically, we use like a common microphone. Basically, I was just looking for one with the USB interface, so it could be attached to Raspberry Pi, which we are using.
And do you do the analysis on the edge on the device, or do you like store MP3s and then upload it and then analyze it?
In this moment, it was analyzed offline. So, I mean, in theory, it could be also used for the edge analysis or for the analysis directly on the device. But it's hard to say if it would require a more powerful device than the Raspberry Pi, which has its limitations. But on the other hand, it is not such important to analyze it right in the moment, because I'm not sure now, but I think every 15 minutes or every 40 minutes I take a sample of sound lasting for 40 seconds, and such sample is later analyzed.
So it's not continuous. It's
Exactly.
Okay.
Because I mean the time constant of the beehive is not such fast that it would require a more a bigger sampling rate.
But maybe there's a question of whether there is any value to, let's say, like recording some singular events. Like maybe there's an application there as well. But I think Shimon and Adam had some like basis in literature for the sampling.
Okay. I actually, this reminds me. I'm trying to scroll back. Couple of weeks ago, or was it? Yeah. We had like a local conference, and I was talking to this guy from our Tallinn Taltech. He was doing something similar that you do with sound analysis, and he was saying that he was using multiple beehives, and in each one he had a microphone because he needs a reference.
Just give me a second. Adam is calling.
Yep. Okay.
Adam. Jo. Proszę się teraz zasądzić, to jest na Kuszkusku z tym wodą. Respektive probíhá. Když to poslal odkaz, tak by se ještě tak pomalu připojit, ale záleží. Jo, proč? Ok, tak, snažíš. Dobrý. Měj se hezky. Čau. Yes, Adam is saying sorry that he won't be able to join because he's out of the computer.
That's fine. He can watch the recording later on. Yeah, but basically the guy was saying that he needs multiple beehives and multiple microphones because of the ambient noise. I don't know if that's a thing, but I imagine if you put one beehive, let's say, near the road, and then you have a totally different beehive in nature, then like the comparison can be different. And so if you have multiple beehives in the same location with the same sort of microphone recording, maybe that helps. How many? I guess I can read about the way you did this study. How many beehives you had, and the sampling, like you mentioned. So that is interesting. But yeah, my focus was not. I didn't want to focus on the let's say analog data, like I call this. So audio, temperature, weight. I see a lot of projects, companies that deal with this, and very little that deal with visual data. And because I work more on with images and video, I'm more sort of focusing on that.
I mean, I agree with you that most of the existing solutions focus on the, as you say, the analog data, or we could say the sensor data. On the other hand, some of the things are much more easy just to capture with, let's say, conventional sensors. I mean, for example, I see, if I would like to monitor the temperature or the humidity in the hive, which also can say how many bees are inside or in which state the honey season is. So then it is the easiest thing is just to put a sensor to to the Hive and capture those data in some regular intervals. I mean, the device which we have combines both of those data, or combines the sensor and the visual data together with the sound ones. And let's say the aim of the final thesis you saw was to merge all those data, but in the end we decided that it would be too complicated, just like for final thesis. And the student focused mostly on the sound analysis, which was slightly connected with the analysis of the temperature and the humidity and the other sensors. But basically he used those somehow to approximate the possible annotations of the sound data.
But like the sensory data that Shimon mentioned could be also used as like let's call it like a free, not free, but almost free metadata for the data set that gives you some like context to the visual imagery that could carry some information that also might not.
Exactly. I mean, for example, as you mentioned the NDVI analysis, that's definitely a question. I mean, by the Hive, which we used to capture the dataset I have, or we have, was just one, and it was in the village, so, or it is in the village, so I guess you could hear a bit of the traffic. You could hear like the people doing some stuff by the weekends and such. But in the, as I say, in the longer period of view, this is just like some kind of ambient noise, but the most of the data you got, or the most distinct data are from the beast itself. So I wouldn't be such worried about that.
Okay. Yeah, I mean that makes a lot of sense. I agree that those are like complementary things, and having audio definitely can quickly pinpoint that. Hey, like you can actually watch what's happening in this phase, and I like the Grafana. I speak with so many different people. Some are immediately saying that no, Grafana is too complicated. Nobody will use Grafana. Beekeepers are all old. You need a very dumb app, and it's so hard to. And at the same time, I look at the like thesis research papers, which has so many rich possibilities that you can provide it to beekeepers, that if they are smart enough and they have enough data gathered, they can combine it to look at after their bees and understand better what's happening. They just don't have access to this. I've seen different cases where everyone is talking about even Grafana in their apps, but nobody's actually using them. I saw one case where scales are used, but I think they use something like Xlog or some web app which doesn't allow good graph management or configuration, and you have only weight or maybe temperature and humidity information, and that's it. You don't know how to, like, you can't really rely on that information that much. If you have that, okay, there was a drop in weight, yeah, probably swarming happened, but that's it. You don't see what happened before. You don't see any cups being formed on the frames. So it's you don't learn from this basically. And if you would have a good web data analysis application, as well as some kind of hardware which talk to each other, and you can see through history, you can learn more.
I mean, it's also kind of complicated to collect, let's say, kind of more extensive data set, because if you would like to recognize the swarming, you will need to get the swarming for several times. If you want to recognize that the bee is not, the queen is not present, then you will have to remove the queen for many times and such, which is kind of problematic if you want to achieve it by, let's say, a normal beekeeper. I mean, together with the colleagues, we try to make a contact with a bee research institute of Czech Republic, and basically they were interested about our device, but in the end, and they also told us that it would be possible for them, because as they are a research institute and they are doing those things to bees, so they were also, let's say, open to the idea that they could help us with collecting the training data. In the end, the cooperation didn't work out because they had also quite full schedule, and our device was not as ready as it could be. But from my point of view, such cooperation will be crucial to get enough of the annotated data of various states which could happen in the hive. That's basically the problem with our data set. I mean, we collected quite a lot of data, I would say, but on the other hand, the annotation state is quite poor. I mean, in the diploma thesis you see, or in the master thesis, the student tried to somehow label the data using the sensors, but I mean, it is also kind of complex, because for example, we were able to say if it was a day or the night based on the sound, which is also kind of logical. But on the other hand, if we would come to some beekeeper and tell him, yeah, we have a microphone and we can tell you like if there's a night or a day by your bees, he would just say, yeah, thank you, but what, what is it helpful for? On the other hand, it could be also used to merge the data to kind of bee activity curve or index, which could be, for example, let's say a bunch of few parameters or even only one parameter, which would somehow approximate how active the bees are, which would be quite interesting. I mean, it could be somehow kind of it could serve as a fast alarm or something like that, which is also somehow briefly described in this thesis, but it also proved to be too complex in the end.
I recently I found this team, or I don't know how to name it. It's pan-European project. I think they are based in UK, but there are also Austrian and Czech members. As far as I understand, they try to also build some kind of robotics. I don't know if you heard of it. maybe they would be interested in also collaborating with you. But as far as I understand, they try to build a robot that looks after the queen as like they're trying to move the camera as the queen moves. But I don't quite understand the point, because you can have multiple frames, but this is what I got from their Twitter. So some kind of camera, also the kind of gantry, and they just watch it. Yeah, if you're interested, you can track them down. It's some kind of Robo Royale project, and they got something like 7 million from Europe as an investment. So interesting. But yeah, I don't know how do we cooperate, because my goal is to basically build a robot. So I try to reach this phase with BWise. That's my kind of golden goal, that it is fully autonomous and it can analyze and send me telemetry data and vision data about my bees, and I may even not need to extract honey from them manually. Maybe the robot can do it, one frame at a time, and basically I can maybe not only take photos, but I could also record videos. So similar to this Robo Royale, but it wouldn't be continuous. It's also be sampled, and you could, if you get a video of behavior on a frame, you could maybe detect pesticide exposure, or queen movement, or something of that nature. There was a nice scientific paper. I think I mentioned this before. I don't remember now. There was an observability hive, and two girls were writing a thesis in Japan on, and it got into Nature journal. They were using also some kind of not the convolution network, but UNet for tracking all of the bees basically on the frame. So my goal would be also this highly dense analysis of visual data, and the images would be just, the audio and the analog data would be complementary. That you can get those, and they can trigger some kind of alert, or be a sign that something is wrong. But yeah, so far I was just building a web app which analyzes images. I went into building this video streaming, so that intercepts with your area, where I look at the counting of bees. I still didn't manage to run it in production. I just got a bunch of video files streamed from NVIDIA Jetson. But the end goal would be to build a robot first for a single colony and then for multiple colonies, so that could be sold basically. And if you have a lot of beekeepers using it, you also get the data, so you can improve and train models to be more efficient, and also detect all of these edge cases, like you have different families for bees, and races. So you detect more edge cases, the model becomes better. So that was the idea. Now, with regards to your project, like you have a Raspberry Pi, and like on one hand, I would want to have a energy efficient device eventually. So something that doesn't require a cable. And NVIDIA Jetson does require like 19 watts, I think. So it's pretty hungry. You can run it in low power mode, but it's still, I think, 8 watt. But the robot itself would still want a lot of energy to move through the frames.
I mean, basically, even the Raspberry Pi solution we have cannot run for very long without an external power. I mean, in extreme, it could run, let's say, for 1 day, but it is just not enough to collect like a sufficient number of useful data. I mean,
I think that,
Mr.
sorry. I think that there is another good reason to use the Raspberry Pi or something like that, which is like availability, because like in the end game, to cover all the edge cases and to get like good data, there will unfortunately have to be a vast amount of it, and that's a lot of devices. And I think that the Raspberry shines because it's just the most basic embedded device you can get, and it's frankly cheap.
Yeah, but you don't run heavy GPU processing on it. You just, run a more statistical model.
On the other hand,
Correct. We've been running mostly collection and some light analysis so far.
On the other hand, there is no big need to have such big computational stations on the beehives localities, because they could be in less harsh conditions, and you could just send the data somewhere to the server and process it, like, let's say,
Basically cloud.
Basically in cloud, exactly. I mean, even by our device, we had kind of big troubles to ensure that everything runs as it should, because we had to put a special varnish on all the models. We had to seal the connectors with Vaseline, and also the MCU chips on the Raspberry Pi with silicon. And still, it was a bit problematic because there were some oxidations happening, and basically it is not designed to be used in the outside conditions.
Yeah, I have.
Let's call it industrial.
Yeah, I have similar problem at the moment with NVIDIA Jetson. I don't know if that's the outside environment that is the problem or something else. I just lose the connection every 1 or 2 days. It doesn't last for very long. Maybe it is because of the SD card that I use. It tries to record all of the videos on SD card and then send them over Wi-Fi to the cloud. And maybe that's the problem. I don't know yet. But yeah, getting it to production use is hard. Zain, yep. You wanted to comment?
Can you hear me?
Yes.
Okay, so there is one thing I want to ask from you guys. As we know that these devices that like Raspberry Pi or Arduino is not for commercial use. So if you make a board on it, and will it be a durable or reliable board, or will it be a useful device for to be used in future? So what do you say about that?
It's also a good point to discuss in this moment. I mean, if we would have a capability to design a custom hardware, it would be definitely a better solution than the Raspberry Pi, because the Raspberry Pi is fine because it's commonly available. But if we could devise something custom, we could achieve better results. In this moment, it's just kind of prototype, which is completely available at GitHub, and together with the colleagues, we don't have any aims to commercialize it in this moment. But on the other hand, we would be happy if someone would build it and test it by himself as well, or improve it.
If we just use this device like Arduino or a Raspberry, wouldn't it be a disadvantage as it can have a short circuit or one little volt up and down, and the device can go blow up and everything can be run. You need to change the device. As when I worked at Raspberry in for CNC lathe and CNC milling machines, I have since our general manager made industry some machines based on Arduino board. But the problem with that was whenever they control the device, and after a few days, that board goes sparks up and gets blow up, and similar things would happen very often. So we need to change that boards very often and after a few days. So we have to convert it into PLC and DI.
For example, by us, the device was able to run for 1 month. If you check the chat in the last link I sent you, there are the instructions how to build the device with some photos, and there is also somehow a description of the things you should do by sealing the electronics and such. So you could check. But using these, we were able to run the device for the whole month in the outside environments, and it worked fine until the flash drive we used got full, and then it got stuck. But the truth is that, for example, we restart the device every midnight because there was also some kind of suspicious problem that the device wasn't able to work for more than, let's say, 2.5 days post median. So together with the colleagues, we just decided that we will restart it every 24 hours, which is safe enough. And even in the case that there would be some problem, you wouldn't lose more than 1 day of data, which is not such bad because, as I said, the time constant of the beehive is quite long.
If I can say something, I have also some experience with industrial electronics and building, let's say, like very resilient electronics for outdoor use is difficult and expensive. And you mentioned like the licensing issues of Raspberry and Arduino platforms. Well, like it depends on the sort of the business model that you decide to go for. Like the way that Shimon and Adam have done it so far is basically the design is public according to the licensing of the of Raspberry, and you can download the whole thing. However, if you want to commercialize it, and there were, say, a cloud application running off of the data of these devices, just make an open source device, let anybody build it, and neatly shift the responsibility onto the builder, as awful as it sounds, and commercialize the cloud service, right? But if you want to build a robot, then I guess there's no other option than bite the bullet and build the hardware. Sorry.
I mean, from my perspective, how can we help you is, how can we help each other is that it would be extremely helpful for us if anyone else would build and experiment with our device, and just use it like to collect the data, which could be shared publicly, for example on the Kaggle or such. And using this big data set, we would get like enough of the training data to detect more complex states of the decloning. We can also help you probably most likely with paralysis detection, because this summer we will experiment, or in the autumn we will experiment with the I don't want to say multispectral illumination, but how would you say, Tomasz? With broad spectral illumination.
Well, I would call it like a selective narrow spectral. It actually isn't
Narrow,
multispectral.
yes.
That's the point.
Infrared.
It is
One of the bands is in infrared, but not all of them.
500 and 800 nanometers.
Mm-hmm.
And this could be probably quite useful in the paralysis detection as well.
Yeah.
And I mean, in this moment, if you want to somehow optimize the robotic beehive is quite ambitious. On the other hand, I see it as a possible task to do. But you will somehow need to solve the monitoring phase somehow. And I mean, we still plan to make our research somehow publicly available. On the other hand, it's a bit sleepy now, because all of the colleagues which were participating on it have some kind of other things to do. But we will try to modernize it and do something with it, with the device, during the summer. So, as I say, it would be good for us if anyone else would have the device, and we can help with building it and getting this up. And yeah, then when we will have enough of the data, we could make some other analysis and solutions which would be also applicable to the robotic beehive, from my perspective.
Mm. Yeah, I just wanted to say that robotic beehive is the end goal. I still want to have a entrance counter as well. I don't know exactly how to package them. If entrance counter would be bought separately, or if it would be bought separately, or would it be a single package? Like, do you buy a whole robot along with the entrance counter? And so, if you sell them separately, then you have more issues with you need to duplicate everything. You need to duplicate power, you need to duplicate CPU and GPU and that kind of stuff. So from your solution, what I find reusable or interesting to me is the all of the components. So you have the entrance, you separate bees into these slots, and you have a working model that counts them. So that's kind of important. I'm not sure I would use Raspberry Pi, and if not, can I reuse some of the components? Can I plug NVIDIA Jetson and take some of these components and connect them? And then how much do I build on top of this? Because one of the ideas was that, okay, I need lighting definitely for stable vision, but maybe if I have a Hornet, I could close the entrance. So I think one of the let's see, I don't want to say competitors, but guys in the US were doing I think something similar. I have them. They didn't share that much information, but at least that's something I saw. So basically a robotization of this, closing the entrance. And I thought that, the Hornet is the one issue. Second issue could be a stealing state. Third issue could be some kind of high winds. that you want to reduce the entrance. So like robotization would make sense there. And then temperature and humidity theoretically could also be tied to this entire module. So you kind of quietly creep into more and more features, and you need to separate at which point do you sell it as an entrance counter, and at which point it becomes this huge CPU, GPU that analyzes everything. First I wanted to share the guys that I was talking about, and another group of people in Australia, they were watching, they were also using, I think, something like Raspberry Pi, or maybe something more stable, but they used 2 cameras from the top and from the bottom, and that way they could see Varroa mites regardless, like from which angle you look at the bee. So maybe that could also help you in your research. Basically, the bees were walking on the glass, and both cameras could see everything. So the US company I was talking about is this Best Bees. They also have the entrance counter, and something like that. And the Australian company with 2 sides was this 2 guys from. It was not like very specialized. They built various things, but yeah, they were focusing specifically on Varroa mites. They had something like this device. It doesn't look like Raspberry Pi, but there are these CSI cameras that seem very similar, and this is how the entrance looked like. They've sent, I think, 2 times per second they were taking a photo, and sending SMS alerts if they saw something suspicious. So just giving you ideas for potential improvement for future work, or something you want to work in the future. But how you could, how we can collaborate is you can send the telemetry data to me. Like if it's images or a sound, I'm trying to build a web app with inspections in mind. So if I get the more data I get, kind of the better. So if I could expose Grafana as a web UI, that would also be kind of helpful. That pretty much anyone can register with a mobile phone, and they could track this information.
Sure. I mean, if you could help us with the Grafana, it would be definitely very helpful for us. And it is also not a problem for us to share the data. And I mean, together with the colleagues, we will be glad that they are used for something. And I mean, if you would like to build a similar device, which to the one we have, for example, using the Jetson and such, please, it's also not a problem, and just feel free to modify it however you find it suitable, because in the end we also want to develop something what will be used, and if there will be like experiments in more directions, then it will be just good for us.
How good was did you analyze the accuracy or precision of your model? How good was that?
Of the bee counting model?
Yeah.
I mean, in the end, it seems that the one which we originally used is not very accurate. On the other hand, we have a more recent one, I mean, I guess I can send it to you already, but let me just check it. So, okay.
So,
Yes, because we wrote together with your colleagues, we wrote one other paper which is not published yet, but it is already accepted to one conference. But just give me a second, I will send it to you because the conference will be soon anyway. So first we need to. So you could check the models we have. However, I will need to finish the call already.
all right. Was nice talking to you then. I will look into the your design. Whoop.
Oh, sorry. It seems that it is not possible to share the stuff in the chat, but I can send it, for example, on Discord if you would like to in the channel. It will be probably easier.
Yeah, feel free to write and raise discussions in Discord.
Yes, so there is the paper about the key content model, and just like feel free to take a look on it. The most suitable seems to use the ResNet or the YOLO instead of the originally proposed model, which is just like it was based also on the classical computer vision methods, but it didn't prove to be such robust as the other solutions in the end.
Yeah, I was thinking of using either YOLO 8 or YOLO 10, which just came out. But
we can share with you the weights we have for even the model. It's not a problem.
Okay, great. That would be great. Yeah, I was searching for YOLO 8 weights because they recently got the a native counting. You just set a line and basically any object that passes through it will count. That's what I wanted for the prototype. And regarding the instability of Raspberry Pi or Jetson, I think that the Jetsons have, well, they kind of sell the dev kit, but if you want to go in production, they sell a separate kit, which probably should be more stable or like licensed better. So that was one of the options, and that's why I kind of push with Jetson, because with the Raspberry Pi you kind of forced to either do a very simple models, or you need to stream the video or images with like to the cloud, and you rely on internet, and the quality is not the best. I was trying out Raspberry Pi 4. The best resolution I could have is like 640. and I'm kind of worried that that won't be sufficient to detect varroa mites. But
yes, I mean, we were also considering to use Jetson-like for the model which would process the data online, and I agree that the Raspberry Pi is just not too powerful for this. Yeah, power.
all right. Well, that's about a general like collaboration and synchronization. Would you be willing to be somehow mentioned in the pitch that I'm sending to investors?
I mean, basically the way as you include us in this moment is kind of okay for me. I mean, as kind of, let's say, external advisors or something like that. So please feel free also to present the research we have and that we are willing to help.
Okay. Yeah, my goal is to get some kind of investment, and then have that funding to continue research and.
We can discuss it also in some later stage and such. But in this moment, it is okay for us as it is.
Did you try some kind of grants to get funding?
Not in this moment, but it's it might be also a thing which we could try in the future. And if we would do, we would think for the cooperation with you. But in this moment, yeah, in this moment, it is a bit busy in the university, and because me and other colleague are finishing the PhDs, and we are focusing mostly on this.
What thesis do you have on PhD? If that's not a secret.
It is not. It is about visual anomaly detection. So basically, it could be also used by the visual data as kind of rough filter to get the suspicious data which would have sense to analyze. Analyze in more detail.
Do you use what's it called? Models which can detect separate limbs and morphometric or something like that?
Basically, it's based on the one-class detection and some kind of autoencoder preprocessing with various feature extraction techniques. But mostly, it's kind of similar to the pattern recognition.
Okay.
Some kind of a SIFT and sort the classical ones.
Okay. Yeah, would be interested to look at all of your research so far. It was very, very cool. Okay, guys, if you have any more questions, feel free to write in Discord, and let's keep in touch.
Okay, let's keep in touch, and we can also meet for some other discussion, and yeah, we can present like what is new by us and such.
Okay.
And also feel free to write if you would have any questions.
Sure. Thanks for the meeting and your time, and see you around.
Thank you very much. It was nice to meet you. And have a good night, I suppose.
Likewise.
Bye bye.
Bye bye.